Hi friends, welcome to Machine Learning Journey. This is lecture 11 of our ML series, and in this lecture we will understand about gradient descent. So, okay, first in the previous lecture we discussed about uh, how model learns. Let's say there is a equation y equals to mx plus c, and you need to figure out the best values of m and c such that it fits into data and can be used to predict on unseen data. Okay, now to reach best value, first you assume some random values, then you change the values. How, we will discuss in this lecture, but what you do, you assume some random values, you change the values, and then you calculate again the error. You check whether error reduced or increased, and according to that you make the decision to change the weights again, and you do this in repetition. Okay, so in this lecture what I will try to explain is how we do this and what is the best method to do this. Okay, first what we can do is we assume that or we just intuitively decides what can be the range of m and what can be the range of c. Let's say m will take place from 1 to 1000. It is our intuition, and we are pretty sure that the value of m will be somewhere between 1 to 1000 after looking into the output and input data with some intuition. Okay, some random intuition. Now uh, we see also, let's say 1 to 1000, these are the values it can take. So what you can do is, the first one is brute force approach. You take all the values of m and c, you make all the values of m and c pairs, and then try each value and check which pair is giving a minimum value. For example, for let's say 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, likewise you check all the pairs. Okay, 1000 comma 1000, and check which pair is giving minimum error, and then fix that with your model, and then check on the test set, and on test set also if it performs well, then you fix that model. Now how much time consuming it is? First you need to figure out the what is the uh, range. Then after range you need to find each you need to check each value of MNC such that, and then you calculate the error and check whether it is good or not. So it is very time consuming, insufficient, and it requires highly computation, because there are only, let's say, two variable as of now. Let's say there are, if say, n variables, and each variables the range is 1 to 1000. So how many loops you will run? Outer loop will be run 1000 times. Inside loop again will run 1000 times. Like n times you will run the loop, and you will have this much of pairs, and you need to check on each pair or each set of variables value, and then you check the error. Then you check whether it is fitting into the test set, and then you decide that what should be our model. Now to avoid this, what can be, is there any optimized method? That's what gradient descent comes into the picture. So gradient is nothing but slope. Okay, so imagine you are standing on a mountain. Okay, you are standing here on a mountain, and there is a fog, so you don't know in which direction to move, in which direction you need to you need to move forward such that you reach at the camp. Okay, your base camp, here is your camp. Okay, so let's say you moving this side. So you move, and what you will check? You will check whether your here's some parameter you will check. Let's say the you move down and your temperature decreases. You check the temperature at every point and temperature is decreasing. It means you are moving in the right direction. What if there is one more mountain here and it's like that? Then if you move here from here, if you start moving here in this direction, and then you check the temperature again got increased, it means you are in more wrong direction, you are moving in wrong direction. Again you come back, and again, like this you makes the decision according to your temperature, and then you move in that particular direction. So This is what a gradient is. Like gradient is all about the slope, and if the sign, whether it is a positive or negative, says that whether to move on which direction, and the value it's like a step, how much step you need to take. Large value means large step you take. For example, I will try explain with some example. Hello. Yeah. So let's say this is what I explained, right? You are on the top of the mountain, and let's say your eyes are covered, and you need to move to your target camp. So slowly you make the decisions according to the slope you feel, and then you take the decisions. Okay. The same thing in our cost function also. Like what eventually we need to figure out, we need to figure out the best values of M and C such that the error is reduced. So we need to figure out such values of M and C such that it has lowest error, right? So lowest error will give you best values of MNC. Now let's say you have draw the graph of cost error and the model weights. There are the different model weights, you values of model weights. Now you slowly move somewhere here, you start with some random values and slowly move towards the value where model cost is minimum. That particular model weights, you decide that this is the best model. Okay. So the if the slope is a large value, the value of a slope is large, then you take large step. When the slope value is small, you take small step. Okay, the value decides the large or step size, and the positive and negative signs of the gradient itself or the slope decides that in which direction to move. Okay, there are many optimized techniques in the gradient itself, where we need to figure out the way we need to move, because it is not a two dimension, it is an n dimensional space, right? So there can be many multiple directions, and then you have very complex graph, and then you need to move towards the minima of that graph, right? So it is in this lecture mainly we discussed about, like in the gradient descent, it is an optimized technique to find the model weights such that it gives the lowest error, or it makes minimum, our model makes minimum mistakes during a generic or unseen data. So that's all about this lecture. Something more mathematical intuition of gradient design we will discuss in the next lecture. So just remember, so don't scared about the word gradient descent. Gradient is just the slope, and descent means we need to move in the direction such that we reduce the error. We need to reduce the cost function. Basically, what is the cost function? Cost function gives you error, right? What is the cost function? Cost function is gives you error. What is our goal? To reduce the error and improve the accuracy. To reduce error, what we can do? We can uh, check all the values of your parameters, all possible values, but that will be time consuming, inefficiency, and very high compute cost. So what you need to do, you need to figure out some algorithm, and the algorithm exists is gradient descent, where you take slope of that equations with respect to some variables, and then you move in that particular direction, or move in that or like change the weights according to that, and then you reach the graph where the minima is there for cost functions. So that's all about in the lecture.